Welcome to this explainer made by Forge College. You know, you've spent the past few modules doing some serious heavy lifting, especially after our last lesson on drafting the comparative analysis. Well, today is the day it all comes together for your capstone project on evaluating consensus mechanisms. We are going to treat your final deliverable not as a boring, run-of-the-mill academic essay that puts your reviewer to sleep, but as the meticulous assembly of a high-performance machine. Think of it like drawing up the ultimate engineering blueprint on crisp beige patent paper. We're going to take all your modular parts and lock them into a submission-ready analysis report. So let's look at the master blueprint for today's assembly line. We'll start with the capstone assembly line, move into your final blueprint, go through a step-by-step report build, hit the quality control checkpoint, and finally, preparing for launch.
Section 1. The capstone assembly line. Gathering your manufactured parts. Okay. Let's dive right into this by checking our inventory to gather all those modular parts you've successfully manufactured in your previous lessons.
Remember, we built this project incrementally on purpose. You aren't starting from scratch today. You already possess the rubric and scoring framework from Lesson 1. From Lesson 2, you have your BFT failure mode tables. And as a quick reminder, BFT, or Byzantine fault tolerance, is really just a fancy way of figuring out how the network survives when some of the computers act maliciously or just flat out break down. From Lesson 3, you bring your empirical data and measurement scripts. And from Lesson 4, you've got your prose drafts and that crucial peer feedback. So this stage, it's purely about assembly.
Moving right along to Section 2, your final blueprint, what done looks like. We absolutely need to establish strict acceptance criteria here so your theoretical building doesn't just collapse on day one.
Evidence-first scoring. This brilliantly illustrates our core philosophy. Every single time you apply a score or make a claim about safety, it needs hard, reproducible data sitting right next to it. Look, trust me, bro, is a great vibe for a weekend road trip, but it is a terrible philosophy for Web3 engineering. Your reviewer shouldn't ever have to guess how you arrived at your conclusions.
Your blueprint demands exactly this kind of feature matrix. We aren't just waving our hands and saying mechanism B is bad. No way. We are pointing a giant, undeniable spotlight on a specific state concentration metric and linking it directly to a defined centralization risk. Every column must be properly labeled and quantified, like a schematic drawn out clearly in dark green ink.
And you must include a visual metric to prove those claims, like a stark, bright orange ink chart mapping out validator state concentration. If you assert that a network is highly centralized, or that finality is probabilistic, meaning transactions are probably permanent but not 100% guaranteed, you need to point immediately to a visual measurement that justifies it. A well-crafted visual tells the reviewer literally everything they need to know in a fraction of a second.
All right, Section 3, Step-by-Step Report Build, Constructing the Machine. Now, what's absolutely crucial about this is how we sequence the construction. If you do this out of order, you're going to end up with spare parts and a completely broken narrative.
Follow this exact build flow. First, create the document skeleton, your executive summary, methodology, results, the whole shebang. Second, integrate your evidence. Lock in an appendix file or table reference for every single rubric cell. Third, polish those BFT narratives from Lesson 2 so they reference your new empirical findings. Fourth, generate your visual tables and charts. And finally, format your appendix, pulling together all those raw files and scripts.
So, the crucial point here is pacing yourself. Use this suggested word budget to keep your narratives tight and focused entirely on the empirical findings. We don't need a sprawling 3,000-word philosophical novel on the meaning of blockchain. Actually, scratch that, your reviewer definitely doesn't want to read that. We need 250 words of a sharp executive summary, 300 words detailing the exact environment and measurement commands used, and a concise 800-word comparative analysis. Stay disciplined.
And when you're writing those sections, precision is your best friend. Never just vaguely say see data. That is an immediate red flag. Be a precise engineer and point directly to the exact file and column where the receipts live. Give them the file name, the date, the specific data point. Make it literally impossible for the reviewer to miss your evidence.
Section 4. Quality Control Checkpoint. Testing the prototype. Before we even think about shipping this capstone, we have to transition from builder to auditor and bring in the inspectors.
This is the ultimate automated test. If a reviewer spins up a clean Docker container, which is basically a blank, standardized virtual computer, and runs your scripts, do they produce the exact outputs you claimed? If your script only works because of some random config file sitting on your personal desktop, it will fail. Reproducibility is non-negotiable.
So run through this strict manual checkpoint yourself. Run the scripts, click the references, ensure your change log actually proves you listen to your peers in Lesson 4. If any of these are a no, well, back to the drawing board you go.
Finally, Section 5, Preparing for Launch, Final Takeaways. We've tightened all the bolts, so let's get the final payload ready for launch. Your final payload must contain these specific artifacts. We need the final PDF, but also the editable source document. You must include a one-page README that explicitly maps your report sections to the rubric items, making the grader's life incredibly easy. Add the appendix folder with your raw data, and of course, that changelog. This ensures the reviewer has absolutely everything needed to quickly verify your robust machine.
Let this sink in for a second. The appendix isn't just a dump for extra text, it's the engine room of your report. Furthermore, transparent trade-off articulation means acknowledging uncertainty. Your recommendation must list at least 2 assumptions that, if invalidated, would change your advice. And your well-documented appendix provides the exact reproducible steps to back up those complex trade-offs. Make sure you keep a copy of these methods safe, because our next course module, Origins of the Web, will challenge you to look to the past to understand the future. You're going to need your current Capstone materials to draw strong parallels between these modern, highly decentralized trade-offs and the earliest web design choices.
You now have a precise roadmap to transform your drafts into a mastery-level deliverable. But before you go, consider this. How will the complex consensus choices you made today compare to the simple, static pages of the early web? Are we overcomplicating trust or finally perfecting it? Think about that as you finish your builds. This explainer was made by Forge College. Please visit forge.college to explore more of our educational resources and dive deeper into Web3 engineering. See you in the next module.